To get the F statistic for a within subjects ANOVA, you take the MS between the time points divided by the MS error, and we have found those both already. So we have 103 divided by 0.33. That gives us a really big F statistic of 312. This F statistic is really big, and it's most likely going to be significant because it's so large. Remember, we're comparing it to a F of 1. Now, just because it's above 1 doesn't mean it's significant, but the more it is above 1, the more likely it will be significant. So the higher the F statistic, the more likely it will be significant, but it does have to be above 1. If it's below 1 or 1, it won't be significant. If it is 1, then that means the between mean square is the same as the mean squared error. So that means that the differences between the time points are no different than what we expect by chance, which is calculated or estimated by the mean squared error. Our p-value is less than our alpha level, so we will reject the null hypothesis that all the means are equal, and we're going to find support for our alternative hypothesis that there is a difference between the means. So we can say that there is statistically significant evidence to support that there is a difference in the average assessment scores between the time points. So we say is because it was significant, the p-value was less than the alpha level. If our p-value was greater than our alpha level, we would say there is not and keep the rest of the sentence there, just like we have been doing in the other hypothesis testing that we have been doing. So that's pretty simple. If the F statistic is significant, then we need to do a follow-up test. The F test is an overall test. So it doesn't tell you where the differences are. It only tells you that there is a difference somewhere, and you need to kind of find where the difference is. So in this case, we had 3 time points. So we're going to want to compare 1 versus 2, 2 versus 3, and 1 versus 3. So we're going to have 3 comparisons. So we can do 3 dependent t-test or 3 dependent t-confidence intervals, either one, but see that we're doing dependent ones because those are paired just like the within subjects ANOVA is paired. So for the between subjects ANOVA, you want to do independent t-test, and for the within subjects ANOVA, you want to do dependent t-test if you have follow-up test. But this is only if your p is less than your alpha. Okay? If it's the other way around, your p-value is greater than your alpha, then you would not do follow-up test. Okay? This is only if you find that there is a difference somewhere. So you find a significant F statistic, then you want to kind of find where that difference is. But if it's not significant, saying that we don't have evidence that there is a difference, so you shouldn't go looking for it. Now, the last thing you need to worry about is your family-wise alpha level. And we talked about this in the Between Subjects ANOVA video. But you want to correct it with something like the Brown-Ferroni correction, the Tukey correction, or the LSD correction. And that kind of just makes sure that because you're having multiple tests or multiple confidence intervals, your overall alpha level remains the same. So your type 1 error will remain the same. And the probability of finding a false positive, a false significance, when there really is no difference, will remain the same. That's your alpha level. Right, and that ends our videos on within subjects ANOVAs.